Eric Burgess here. Each American uses an average of 525 pounds of paper in a year. Suppose that the distribution is approximately normal with a population standard deviation of 150 pounds. Find each of the following. Alright, so we're just going to sort of tackle these one at a time, but it's just some basic standard normal distribution knowledge will go a long way. And we are going to be using both the calculator and the chart to do this problem. So let's just dive right in. So first up, A, if an American is randomly selected, find the probability that the person uses more than 750 pounds of paper. All right, so step one for us, we're going to draw a chart. And we're just going to draw a normal distribution on it because we were told that it's approximately normal. And in the middle is our mean, which is going to be mu. And then we're going to move out in units of standard deviations. So we say, okay, well, we need a z-score because what we're going to do is we're going to do, so this is for the x, but we could have another set for z. So I'm just going to use the same chart for both. So z-score, the mean is always 0. And recall that z is equal to x minus the mean divided by sigma. And we've been given the mean. We are told right here that the average is 525 pounds. So mu is equal to 525. And we were given sigma. We were told that sigma is 150. So we put down 150. All we need is an x value, and we were even given that. We want to know if the person uses more than 750. So that's going to be x is equal to 750. And we want the probability that this happens. So 750 is beyond the mean. So our mean is 525. So in this middle part for the x-axis, that's 525. And then we go up some number of standard deviations away, and we hit 750. It's above the mean. And we want the probability that it's greater than this. So we say, okay. Now the calculator can actually handle the x values directly. If you come into the calculator and turn it on, go to stat, and then over to, oh, whoops, not stat. We want a distribution. So we're going to go to second, and then in blue, distribution. And we're going to come over, and we want the normal CDF. And our lower value, well, that's our 750 that's right here. That's the lowest because we want to start here and go up to infinity. So we're going to start at 750. And our upper value is a super big number. And so we could type a big number by typing 1 and then taking these two E's. You hit the blue button to get to them. And this basically says how many zeros go after this. Well, we're just going to put 99 zeros. So this is 1, 0, 0, 0, 0, 0, 0, 0, 0, 99 zeros. Super, super big number. So big, it's basically infinity for us. Now our mean, since we're using x values, we are using the actual values from the problem, our mean will be 525. And our standard deviation will be the standard deviation we were given. So that's going to be 150. And we can put this in, hit paste, and it'll actually tell us what it is. So we would say, and now formally we would say the probability that x is greater than 750, because we wanted it bigger than that, is equal to 0.06, and I'm going to round to 3 places, 7. And I'm going to replace this with approximately just to be super duper precise, or approximately 6.7%. And that would be our answer. Like that would be it. But that's using the formula, and some teachers don't like you skipping the chart and they want you to use the z version. So we can get the z-score pretty easily by using this formula, right? So z is equal to x, which is 750, minus the mean, which is 525, divided by the standard deviation, which is 150. So we get that z is equal to, let's find this out. We're just gonna put this in. So we're gonna do 750 minus 525, hit enter, and then divide by 150. And we get 1.5. So it's equivalent to a z-score of 1.5. Now going back to our tests, we can actually go to, or not tests, go to the distribution. So yeah, we want to go to the distribution because we're dealing with a normal distribution and we want values about this distribution. So we're going to go back to the distribution menu in blue, and we're going to go to normal CDF again. And this time, our lower value, well, we're saying on the z-score that 750 is the same thing as the z-score of 1.5. So on the z-axis, we'll have 1.5. I'm going to draw my arrows here because they go on forever. And so 1.5 off to infinity again. So this time our lower value is actually 1.5. Again, we go off to infinity, so that stays the same. Z-scores always have a mean of 0. That's our middle, so that's 0. And a standard deviation of 1. And then we're going to go ahead and hit paste. And we get the exact same answer. Now, we can also find this answer using the chart. Now, we're finding the area to the right. And so in order to do that, we have to do 1 minus the area to the left because the chart always gives us area to the left. So we go to our chart with the z-score of 1.5. Let me pull it up here. Here we go. We want the positive side. And we want a z-score of 1.5 right here. And then 0, 0 is right here. So 1.5. That corresponds to this guy right here, 0.93319. So we're going to go back. We're going to do 0.93319 was the area to the left. All right, so that's this area that's not shaded. The chart always gives us area to the left. And so now we just do 1 minus this, and we're going to get an answer. We're going to get 1 minus 0.93319. Hit enter, and lo and behold, we get the exact same thing. So if the first two ways didn't convince you, hopefully the third one did. And so you would write your answer out. This is the formal way to write it out. This is how you should write it. Probably x is greater than 750 pounds is approximately 6.7% or 0.067. And I guess we should write in what we got here. We got 0.06681. But there's two ways to use the calculator. One way using x values, one way using z values, and then there's a way using the chart. So if you want to triple check it, you can totally do that. Or I guess double check. The first one's just the answer. All right. So moving along here, if an American is randomly selected, find the probability that the person uses between 520 and 730 pounds of paper. So again, we start by drawing our chart. It's always my first step anyway. And we draw in a normal distribution, like something, wow, it does not look very normal. Here we go, whatever. Good enough for whatever we're going to do. And we want between 520 and 730. Now our first axis will be our x-axis. Our second axis we'll put the z-axis. And this time I'm going to skip the x values, but you can continue to use x values if you want. I'm going to just use z values so that I only show the calculator way one time. So, okay. The middle is still 525 for x. And for z, it's still 0. That does not change. But they're asking about different x values now. They want in between 520, which I'm just going to pin like right here-ish. There's 520. And we'll put a line here. And 730. So 730, somewhere up here. 730. I'll put a line there. And they want in between. So all the stuff that's in between these two. So, okay, this should not be too bad. Now, we need to convert both these x values to z-scores, and we're going to use our z-score formula here. So let's convert 520 first. So it's literally the same thing we did before, except for now, I'm going to call this z1, because it's going to be our first z-score. Instead of x being 750, now it's 520. And we do minus 525 divided by 150. And we've already typed in some of this. Well, I didn't type it in all nice. I'm going to type it in nice this time. I'm going to type a fraction. So I'm going to hit the green key and then the green F1 menu and choose number 1. And then I'm going to type in 520 minus 525 divided by 150. And we get an answer out. It's a decimal. I'm going to go back to that F1 menu and turn it from fraction to decimal. and we get negative point. So we're going to type that in, negative 0.033. So that's our first z-score. Our second z-score, z2, is going to be 730. Only x changes because the other things, the mean and the standard deviation, didn't change. And so we expect this one to be positive because it's bigger than the mean. This one was below the mean, and so that negative 0.033 falls right here, 0.033, and it's negative because it's below 0. It makes total sense. It's less than the mean, so it's below 0 on the z-score, because on z-scores, the mean is 0. So, okay, now we go ahead, we type this thing in, but you can actually just copy what you wrote and put in 730, and just hit enter. Again, we need to convert, so we hit the green key in F1, and we go to fraction to decimal. And we get 1.37. So this value as a z-score, 730, corresponds to 1.37. All right, so on the chart, we look up the bigger one, and we subtract off the area from the smaller one, and that will give us the area in between. Or you can just use the calculator. So I'm going to go to the calculator. So we're going to go, well, first we'll do calculator. We'll do the chart too. So we're going to go to the distribution menu again. So we're going to go second distribution and then normal CDF. And this time we have two clear values. So you could use X values and the actual mean and standard deviation and enter, and it will give you the same exact answer. I'm just going to do the z-score version. So we're starting with a lower value of 0.033, and it's negative. So we put negative 0.033. Our upper value is positive 1.37. So we put 1.37. Our mean is 0, and our standard deviation is 1 because we're using z-scores. That's what this formula up here does for us. It turns them to 0 and 1. And then we're going to hit paste and hit enter. And it gives us the value in between. So the way we would write this out, all formal-like, is the probability that x is in between. So we'd write x, and then this is how you write in between in math speak, is between 525 pounds and 730 pounds is approximately 0.429. If we round to 3 places, or 42.9%. So that would be our answer. You would box this and you'd go on your merry way. Now, let's go ahead and check this with the chart. So in the chart, we simply look up the bigger one and subtract off the smaller one. So we have to look up positive 1.37 and negative 0.033. So let's go ahead and do that. Let's go to our standard normal chart. And we want positive 1.37. So here's 1.3. Let's go over to 7. So it's this guy right here. So I'm going to just type this in, 0.91466. We're going to subtract off, and then we want 0.033 on the negative side. So we go to the negative side, and we look for 0.0, which is down here, and then 0.033, which the closest we can get is just 0.03. So that is this one right here, 0.48803. All right. Now let's go back to what we had. We expect our answer to be close to this. We hit enter, and lo and behold, we get 0.42. And then there's a small discrepancy. That's totally fine. There's some rounding error going on here because we were using the chart. The calculator is more precise. But you can see that is how you do that. And also, the chart only goes to 2 decimal places of accuracy, at least the one I had. So that's also another source of why there's a bit of difference between the two. But it's very, very small, reasonable amount of error. And so there you go. That's how you would do part B. Now, finally, part C, it says the people at the bottom 15% of paper users, or paper use, so they don't use very much paper, are very conservative. Find the use in pounds for the bottom 15%. Oh, I forgot to put my arrows here to show that these keep going. All right, so we got to find this bottom 15% of people. So how much paper can you use and still be considered very conservative? So what they're really asking is, okay, here's our chart. Let's draw our chart. And we're like this. And then there's our mean in the middle. There's a bottom 15% here. There's 15% or 0.15, 15%, however you want to look at it. And they want to know the x value that goes with it, right? If this is our x-axis. And then we've also got a z-axis. And this is going to be useful to us because we say, okay, well, we want to know what this is. There's a really, really easy way using the calculator. So let's do that way first. So in the calculator, there's actually an inverse function. So normally we're looking up z-scores like we did up here. And then we get areas. And that's what our probabilities are. But here, we're starting with the area, and we want to go backwards and get a z-score. So what we're going to do is, and in fact, we can actually get the x-score directly. So we're going to go ahead and go to the distribution menu again, and we're going to go to inverse normal. So this is going to undo. It's going to go backwards. We give it an area, and it tells us. So here we do an area, and so our area is going to be 0.15. And okay, if we use a mean of 0 and a standard deviation of 1, that will go to a z-score. So if we use this and hit enter, we get a z-score, which will be very useful to us. So we're going to type in negative 1.036. All right, but let's go back. Whoops, wrong button. You got to hit blue key first to get the distribution. And you can actually type in your mean and standard deviation. So our mean was 525. And our standard deviation was 150. And we can go ahead and hit paste. And this is the actual x value. So it turns out that in order to be in the bottom 15%, so I could say in order to be conservative, in order to be in the conservative range, you may use up to 369.53 pounds. So that's how much paper. If you use more than that, you're not conservative anymore. You're outside of the range. Now let's go ahead and compute this another way. So say we didn't have this, then what would we do if we didn't have the calculator? Well, we would use the chart and the z-score. So what we'd do is we'd look up 0.15 in the chart. So let's go to the chart. Where's my chart? We would need to find in the areas 0.15, and we would just go backwards. So this whole time we've been going, into the chart. We're going to start in the middle and come out of the chart like some sort of scary movie. So we're going to go for 0.15. That's what we're looking for here in the middle. So here's 0.11. And let's keep going. 0.151. 0.149. So this looks pretty dang close. So if we look at this going out corresponds with -1. And if we come up here, 0.04. So we would go back to our thing when we'd write z is approximately -1.04. And if we look at this, if we were to round this one the calculator gave us, we would get this. So this is just due to a rounding error, which is why ours is slightly different, but still totally useful. And then we would need to say, well, normally z is equal to x minus the mean over the standard deviation. But in this case, we want to get the x value. We found the z-score. We need to find out how many pounds. So what we would do is we would multiply by sigma to both sides. And this will cancel the sigmas out on one side. So now we have z times sigma is equal to x minus mu. And then if we add the mean to both sides, if we add the mean, these cancel out and go to 0. These ones went to 1. That's why they disappeared. And we get mean plus z times sigma is equal to x. So now we have a formula, and some of you guys may just have this one memorized. And so what we're going to do is simply plug it in because we have a z-score, we have a sigma, and we have a mean, right? Our mean was 525. Our z-score was -1.04, and our sigma was 150. Let's see what this gives us. It's not going to be exactly the same because we had some different rounding, but it's going to be really close. 525 plus parentheses negative 1.04 parentheses 150 close parentheses enter. Look at that. We get 369. So you see this one's a smidge more precise. And it's important to recognize that we converted to x. So we went from z-score to x, and our x values were in pounds, right? We were always dealing in pounds. How many pounds of paper? So this is the pounds. And then you would write like a sentence stating what you would need. There's not like a super fancy way to write this one. It's kind of just a number. But you want a sentence to show that you know what this number means. So if you use less than this, you're gonna be here or less than that. And you'll be in the region that is not using too much paper. You'll be conservative. So that's that. That's how you do this one. It's a lot of just sort of manipulations about the distribution, checking your knowledge of if you know how to manipulate it. If you have any questions about this, let me know. Feel free to stop by online tutoring. We're there to help you if you are a Citrus College student. Subscribe, and we'll catch you in the next problem.